Thanks for having me. It's a pleasure to be on the stage again, more or less the same stage after this morning. I'm going to be talking about believable AI characters and how you need to combine both conversational and behavioral AI. And I've thought long and hard when I prepared this talk, because the one thing I cannot stand in talks is when they're just disguised sales pitches. So hopefully I'm gonna be able to convey real information here. My dream is to have more actors work in this field that I love, which I've been working in for more than a decade. And if some of you end up developing tech that competes with us, then I couldn't be happier, because it means that the mission of this talk would have been accomplished. Now, let me start in a way that's a little bit similar to this morning, talking about the dream of AI characters. If you have watched movies like Her or Blade Runner or Ready Player One, you know that great AI characters are a sci-fi dream. They're kind of obvious. They're like the low-hanging fruit of our visions of the future. We all want them. We don't have them. They're always portrayed as highly desirable and believable and beautiful. And gamers can't wait for them. Now, even games have, of course, featured some form of AI characters. In fact, more than 50% of games today, if you look at the top 100 games on Steam or so, top mobile games have AI characters. In XR, it's more like 60% of the, let's say, the top 25 best-selling games on the Quest store. But the problem is that players aren't impressed. Here are some, I would say, representative examples. Actual gameplay from Cyberpunk 2077, actual gameplay from Pokemon Go, AR. That's a $4 billion game, and the NPC interactions that you get to have in this game and many others are kind of without words. AI characters feel uncanny, they feel scripted, and they feel robotic. Now, startups today are already trying to change that. Especially by focusing on conversational AI. This is a demo that NVIDIA launched a few months ago, showing beautiful graphics, a very well animated character, and of course you can see subtle camera movement. This was very well polished, almost cinematic. However, if you look at what's actually being offered beyond eye candy, it's really just a character that's all talk and no action. Because while the character talks, okay, they use the same ChatGPT that all of you can use for a few dollars a month. The animation is just a loop. And idle loops is something that game animators already know how to do very, very well and very cheaply. So if you look at the products that are being developed, you have to see that the quality just isn't there yet. We kind of have this wish for AI characters that can converse with you in a believable way, but the characters just stand in front of you, they mansplain you or womansplain you, they feel uncanny, and they feel very static. Professional game devs have already dismissed this, and they are not convinced by the current hype around AI characters. That's why we have come up with the concept of behavioral AI. Behavioral AI is all the systems that you need in order to power characters that feel alive. They don't just sound alive, but that feel alive via the things they do with their body, with their faces, with their limbs, and so on. This is one of our many demos. It's running on Quest 2. When we show this to players, like, they tell us after the demo that they feel that the character is alive. By the way, I have the demo with me. Find me after this talk if you want to have a live demo on Quest 3. And of course, like, we at Virtual Beings, we don't just do bird characters, we do all sorts of characters. And let me talk a little bit about the nuts and bolts. What do you need? If you want to build something like this, what kind of tech do you need? For behavioral AI, we're talking about three different problems, actually. First is the problem of virtual cognition. That means that you are able to teach the AI character what's happening around them, what they can do with space, where they can go, where they can hide, all these kinds of things. That's called virtual cognition. And you need to solve this well because current game engines do not solve it well for you. In Unity, in Unreal, in order to get from A to B, even in a trivial game, you have to do what's called baking in NavMesh, which means that you define at a time what your environment looks like, and at runtime, it can, for the most part, not change. Of course, that's not how the real world works. In the real world, things move, doors close, objects appear or disappear, things are built, things are being destroyed. The second component you need is procedural animation. A lot of people who watch our demos find them convincing, but they don't quite know what's happening. They think, oh, this is just a very cool new form of animation. And that is true, but it's also different because in a traditional animation pipeline, everything is canned. Everything is defined in advance by the animator. Of course, that doesn't work when you have interactivity. If it's the player who decides what an AI character does or where the character has to look at, then everything has to be procedural. And you need to have a system, a sophisticated system that combines canned animation or motion capture or AI-generated animation with the needs of the game at the moment. And finally, this is probably the most mysterious problem, and we'll not be able to go deep into it today because this talk is not about behavioral AI per se. You have the problem of behavior synthesis. Think of it. If you walk on a road, you're walking along the road, you are maybe looking at your watch, and 1 second later you see a friend on the other side of the road and you're waving at them. Now, did you have to stop walking in order to greet your friend? No, because it's normal, right? That's what people do, what animals do all the time. We do more than one thing at a time, and we do it on different timelines. And that is trivial when you think about real people, but when you think about AI characters, it creates an immense problem, which is that you have to coordinate multiple things on the same character rig. That's the problem of behavior synthesis. Now, in order to take inspiration from the real world, which you always want to do, you also need to understand a little bit about how behavior works in the real world, which is why we at Virtual Beings have come up and we've published the 12 principles of behavior. A nod here to the principles of animation by Walt Disney. Behavior is interactive, it's sequenced, and so on. And you have to respect how behavior works in the real world in order to transcribe it into the virtual world. But the most important principle is always to observe what is really happening. For example, here you saw our animator being inspired by a bird sneezing. Turns out that birds can sneeze. I didn't know that. And it's insanely cute if you do it well. And here you see a little bit of our workflow, right? We start with a source animation, but then we adapt it procedurally using our own tech called Qt Engine in order to make it interactive and make the bird, for example, have different body postures, look at different directions, have different facial expressions, all while using the sneezing animation. Now, where does conversation come in? That's, after all, what the talk is about. So, conversation is a form of behavior. Here I want to walk you through a clip with Ross from Friends, who many of you may remember. I'm going to walk you through it. So Ross's girlfriend says, "This is my father, Paul Stevens. Dad, this is Ross Keller." Ross Keller says, "It's great to meet you, Paul." Paul says, "Usually I prefer Liz's boyfriends who call me Mr. Stevens." Look at it in slow-mo. It's always worth to analyze behavior in detail. Slow down 50%. When introducing, Liz uses a gesture. Ross makes eye contact with his girlfriend, then takes a differential step towards the girlfriend's dad in order to reach out and greet him. Bruce Willis, the dad, stays in his place, assumes a dominant posture, and makes a snipey remark, the kind of remark that in the 90s people thought dads would make towards boyfriends. And you see how things that people do with their bodies and things they do with their voice are interlaced all the time. This is the normal world, right? This is how conversation works. There's no such thing as conversing without using your body. That's something we invented 100 years ago with the telephone and nowadays with Zoom calls. But it's not fun to have a Zoom call with an AI character, right? There's no value there. I've not had a single gamer ask me for more Zoom calls with AI characters. Instead, they want to have the real deal. They want to have the full interactivity. So the problem is that conversational AI and behavioral AI, they require different tech stacks. And I'm going to be quite fast here. We have a lot to go through, and this is just a tour d'horizon, so to say. Conversational AI, as many of you know by now, that is powered by so-called large language models. They're called large for a reason, because they are big, and therefore they are served via the cloud. They cannot run on your mobile phone, and they cannot even run on your PlayStation 5. They are standard things, blobs, that big corporates develop for you, and that you can then adapt through a process called fine-tuning. So you can download a version of, let's say, Llama 2, trained for millions of dollars for you for free by Meta. You can just download it, then you fine-tune it, you teach it what characters typically say in your game or your product. You can use a process called RAG in order to have it access real-world knowledge about anything and integrate that into the game at runtime too. And then finally you do something that you all know if you have ever used ChatGPT, which is prompt engineering. You teach the model via prompting to constrain the outputs. That's how conversational AI is done, and that's, by the way, how all the big players in world, Carter, Convey, which you saw in the NVIDIA demo, use these LLMs. There's no mystery. All of you can do it, right? It's just a matter of spending a little bit of time to learn it. Behavioral AI is very different. Behavioral AI is not one problem, it's a myriad of problems, like you saw before. It uses specialized algorithms for pathfinding, for steering, for animation, for behavior synthesis. It has to run in real time. And when I say real time, I mean at 72 frames per second. Because when you're interacting with a bird perching on your hand, and you are maybe, I don't know, throwing food at him, or you are penetrating your finger into her body, you want there to be a reaction. You don't want to have to wait 2 seconds, right? This is not how real animals would behave, and it doesn't feel satisfying. So it's real time, and it can use machine learning, but those machine learning models have to be small. So as a ballpark measure on console and PC, you could do sub $1 billion models. On a mobile phone, on a VR headset, you could probably do 100 million parameter models. More on that in a second. One thing I want to mention here is that you see that in the conversational AI tech stack, the LLM is really at the center, and in the behavioral AI tech stack, the code is at the center. And this is now a well-understood metaphor, like, for example, by AI influencers like Swix here, LLM Core, Code Shell versus Code Core, LLM Shell are the two major development paradigms of the coming decade. This is how your startups or the startups you're competing with are going to have to decide how they are going to roll out their tech. Do you have an LLM and you engineer a periphery around it via prompt engineering and RAG and so on? Or do you have code at the core and you just selectively loop in LLMs whenever you need to? Deciding what direction to go is actually simpler than you may think. If you are into AGI or you want to build an autonomous agent or, I don't know, virtual therapist, you're probably safer betting on large and very large LLMs at the moment, because this is the kinds of problems they're good at. But this is not what game development is about. Game development is about not just delivering real-time experiences, but delivering controlled experiences. Because you don't just want your villager in The Witcher to have a conversation about philosophy or, I don't know, conflicts in the South China Sea. You want them to give the player a quest. And this has to be at the right moment. It has to be satisfying to the player. It has to be measurable. There have to be analytics. This has to be monetizable. And I mean this in all seriousness. This is not a bad thing. You have to be able to hook into main beats, into gameplay beats and story beats of your game, and know what the player is experiencing. This is just how game development works, and you need code to be at the core of that experience. So this is not just about cost and latency, it's also about control. That's why the only work I'm personally interested in at this point is code core. If you want to build AGI, power to you. I'm not going to be able to help. Now, if you go code core, there's a bunch of problems that you're going to have. Specifically 4, and I'm going to briefly touch on all of them. First problem is, how can you understand what the player says? Second, how can you respond to the player? Third, how can you take the initiative in conversation? And finally, the most important one, how does all of this tie into game design so that you can have the kind of controlled experiences that I just mentioned? I want to address this with quite a few examples. First of all, the problem of understanding the player. This absolutely does require ML. There's no second show in town at the moment. It is doable in real time, but it really requires cutting-edge technology. And it also requires, and that's kind of bizarre in this field, it also requires a little bit of knowledge that's not technical, that's more social scientific. Here, one of the knowledge bases we found useful is from linguistics, specifically speech act theory and a theory called cap theory, of which I am one of the contributors back in the day when I was still working in academia. This is about, like, what is it that players do or that people do when they say things? Speech act theory has a well understood solution for that. What you do is you carry out speech acts like greeting someone, like promising something to someone. And this can then be decoded using machine learning, and your game can be taught to not just understand utterances, but to understand speech acts. We have a tech setup. I can quickly demo this to you. It uses Unity Centis, which is currently in beta, which is Unity's tech stack for solving machine learning models on device, super fast. Uses a library that just came out called Sharp Transformers, and just for the nerds of you, it uses BERT-based sentence classification. So here, just one example.
Hi, little bird.
Let me, this was a bit fast.
Hi, little bird. Yeah.
So the fact that you address the bird is not enough. It also matters in this kind of scenario what you're saying. So here the bird character is running a bird-based encoder model that basically tells you what is the most likely thing the player is trying to achieve by speaking to you. And decoded that this was a solicitation and responded behavior in the way you just saw. Now let's take a different character responding to the same
Hi, little bird.
Come on, do I really look like a bird to you?
Okay, so Gary the robot here, he first of all knew that you were addressing him because you are looking at him in his direction. And he knew that you're not looking in the bird's direction. And then he tried to understand what you're trying to say, but was confused, used, again, machine learning on device, couldn't quite make sense of what you're saying, and came up with this answer. Quickly, maybe one more, or one or two more videos, and then I want to also open up for questions. Problem 2, responding to the player. This is doable both with and without cloud-based machine learning. I'm going to skip over the cloud-based part for the reasons you already know. I'm not a fan of it, but it's very hard to do it well without cloud at the moment. You can fake your way towards it. For example, you can do a lot of pattern matching. You can have GPT-4 generate data for you to match against. And you can use very small language models that are specifically fine-tuned for the task of responding to the player. And then you get outputs like this.
Hi there.
Hello, how are you?
Want to play a game?
Sure, let's play.
So this actually used our, our part of the engine that talks to a cloud engine, to a cloud backend. So specifically, the language model we used here is called Llama 2.
You're a quick learner.
Thank you. I try my best.
Your move?
All right, let me think.
Okay, finally, just glossing over the last problem, taking the initiative to talk. Again, we solve this by combining technology with social science, specifically speech act theory again. Ping me for the slides afterwards if you find this too fast. The specific approach we use in our tech is to define parametric speech acts at editor time and have the character initiate the talk at specific gameplay beats, which puts gameplay first and which allows the feeling for the player that what the character is saying is unscripted, but it's still tied to the gameplay. It's still making sense. Show you an example.
Oh shoot, did not see that.
See, Gary reacted here to something that was happening on the chessboard and took the initiative to speak.
Hey little one, come here.
And again, reacted to gameplay and took the initiative to speak. Okay, I'll stop here, and we have 2 minutes for questions.
All right, who's got a question? Okay, do we have a mic in the back? Yes, thank you. Applause is very important. Okay, so I'm going to bring you the microphone so we can get you on the recording.
Hi, thanks for the awesome presentation. My question is about when you're integrating LLMs into the conversational models into the characters, how do you prevent the jailbreaks? Basically, having the users goad or convince the conversational AI into some unintended behavior.
There's no perfect solution for that. It's because these models are non-deterministic by nature. However, the problem is just less urgent. First of all, we, in our own demos and showcases, we prefer voice-based interaction, and it's hard to have a precise jailbreak prompt uttered in your voice, right? So that's one safeguard. And the other is that we just use fine-tuning. And when you fine-tune the smaller versions of the large language models, you really constrain what the model can say. And you're using, so the fine-tuning customizes the model. That customized version is not publicly available. So it would be hard for players to really iterate over prompts to jailbreak what they do. And I mean, what can they achieve? Can they make Gary the robot say nasty things to you? Probably. If that's fun for them, okay, I have no problem with that.
Okay, we've got 30 seconds. If anyone have a quick one? All right, let's give another round of applause to Wendelin, and you can catch him outside.